This video lesson is on scatter plots, lines of best fit, regression, and association and causation. So it says, use the following scenario and table for questions 1 through 6. Sarah recorded the weights of dogs and the time it took the same dogs to complete an agility course in seconds in the table below. So our 5-pound dog took 20 seconds. Our 19-pound dog also took 20 seconds. Our 22-pound dog took 32 seconds. Another 22-pound dog took 42 seconds. So you see how that works. It says graph the data. So my 5-pound dog is 20 seconds. My 19-pound dog is also 20 seconds. My 22-pound dog, 32. Another 22 was 42. 38 is 60. 40. Oh, down to 50. 52. 58. 60. 66. 66. 80. And 72. 64. Okay. Number 2, complete this statement to describe the relationship in the data. The data appears to have a positive linear correlation. So I can see that it looks like a line something like that. That doesn't actually look very straight. Let me redo that. Actually, I can do this. This will be better. There we go. That line looks pretty good. Move it up a little bit. Definitely modeled by a straight line. Definitely positive. Okay, generate the equation that represents a line of best fit. Okay, this is where I'm going to go to my calculator. And unfortunately, I have to use all of these data points. So this is going to take me a little bit of time to type in, but I promise it's a lot easier than doing it by hand. Okay, so on my home screen, on my home screen of my calculator, I am going to, on my home screen, I'm going to go to new. Oh, it actually took me where I wanted to go, but I didn't show you that. So if I go to new, I'm going to go to this lists and spreadsheets. And all the way up here in A, I'm going to type weight. Over here in B, I'm going to put time. You never want to put anything right here. And now I'm going to start to input my data. So 5, 19, 22, 22, 38, 40, 52, 60, 66, 72. All right, and my Y values, my time was 20, 20, 32, 42, 60, 50, 58, 66, 80, and 64. Okay, you have to make sure that you press enter after the last one. If you leave it like this, the calculator is going to have some issues. Okay, from here, you're going to go to menu, statistics, stat calculations, and we're going to do a linear regression because we already decided that this was a line. So we should recognize this mx plus b as slope-intercept form. The calculator is going to give us the equation of the line that models this data. So our X list, we had in A, that was weight. And our Y list we called time. Now I know a lot of times time is actually our X, but in this case, it's the weight that influences how long the dogs take. So weight is independent, time is dependent. Okay, you don't have to do anything else. Leave everything else where it is. And got to scroll up a little bit. So it says my M is 0.826419 and my B is 16.4738. So I'm going to actually use all of the digits that they give me. I'm not going to round anything. Okay, so let's go down here. So my equation again was y equals 0.826419. Eight 26419. 826419. X plus 16.4738. Did I get that right? 4738. I did. Okay. What is the correlation coefficient for, what is wrong with this? What is the correlation coefficient for the data and the line of best fit? So we find that right here. It's the R squared, not the R. It's the R, not the R squared. This one is the correlation coefficient. It's the R, 0.917786. Okay. So it's asked, does the correlation coefficient support your statement in problem 2, that it's positive and linear? Well, yes. This supports a positive linear correlation because a positive is going to be a positive number. And the closer this is to 1, the more linear it is. So I'm going to draw some pictures to show you. So an R value of exactly 1 would look something like this, where they're all in a straight line. Now we know that this wasn't perfect, but most of our dots followed the line pretty well. So a 0.9 is going to, a 0.9, a 0.91, 0.92 is going to look like what we had. So like you can still tell it's a straight line. Some are a little higher, some are a little lower. If your R is more like a 0.7, you're going to see a little bit more highs and lows, but overall you're like, I still see that it's trending up. An R value of -1 would be a perfect straight negative slope. An R value of a -0.9 would be like pretty good, kind of like what we have in our data, but just going down. So the closer it is to 1, the closer it is to a straight positive line. The closer it is to -1 is a perfect straight negative slope. Use the equation from number 3 to predict how long it would take a dog to run if he was 90 pounds. Okay, this is why I said we are not rounding at all, because if we round, we're definitely going to get very different answers here. So the weight was our X, so we're going to find Y. So we need 0.826419 times 90 plus 16.4738. So I'm just going to go to my calculator, go to this, just the scratch pad, and go ahead and type this in. 0.826419 times 90 plus 16.4738. 90 point, were they whole numbers on that? Yeah, so we can round that one. 91 seconds is what we would get. Okay, I will continue in the next video.